This videograph was prepared on behalf of the bean industry by Professor Howard Schwartz and Research Associate Mark McMillan from the Department of Plant Pathology and Weed Science at Colorado State University. The video will review research results from university and industry programs. Objectives of this videograph are to diagnose bacterial diseases, understand factors which influence disease development, and review timely and economical disease management strategies in relation to common production practices. These diseases of beans are caused by bacterial pathogens living on and in plant tissues. These organisms can be recovered from plant parts, grown on artificial media, and identified by their colony characteristics. Halo blight is caused by Pseudomonas syringae phaseolicola. Small, isolated, circular greenish-yellow halos develop on the edges and centers of affected leaves in the plant canopy. A lesion can develop within 7 to 10 days after infection. Note the isolated water-soaked spots that form on the lower surface of infected leaves. These greenish yellow to yellow lesions and water-soaked areas can coalesce and affect a large portion of the plant canopy, especially in the upper to middle layers. The yellowing around lesions and systemic infection of newer growth is caused by a bacterial toxin. Infected plants can be stunted, yellowed, defoliated, and killed by severe outbreaks of halo blight. Water-soaked spots can also develop on pod walls, pod sutures, and seed. Bacterial brown spot is caused by Pseudomonas syringae. This may initially appear as dark streaks or spots in the field. Brown spot lesions are concentrated in interveinal areas of leaves. Small, light yellow halos may develop around water-soaked areas. Water-soaked lesions can develop within 7 to 10 days after infection. Note the isolated greenish-yellow lesions of halo blight on the right and the general yellowing of brown spot on the left, and numerous small brown spot lesions above and a large common bacterial blight lesion below. As bacterial brown spot lesions cover more leaf area, they become more tan to brown. Lesion centers fall out and produce a shot hole effect, and leaves become tattered. Leaf cupping can be associated with bacterial brown spot infection of young expanding leaflets. Infection may be more apparent in upper or middle layers of the plant canopy depending on when infection occurred. Leaf cupping and plant canopy stunting are often associated with moderate to severe outbreaks. Tan to reddish-brown lesions may also develop on plant stems and branches. Plant stunting, defoliation, and death can also occur. Large brown water-soaked lesions can develop on pods, pod sutures, and affect seed quality and yield. Survival of bacterial pathogens is common on and within seed harvested from infected plants. Common bacterial blight is caused by Xanthomonas campestris phaseoli. Note the outbreaks of common bacterial blight, which often appear after flowering. Water soaking is again very apparent on the lower surface of an infected leaf. Young lesions have a large tan to brown center, narrow yellow halo, and slightly wilted or scorched margin. Lesions may be located on the edge or center of leaves. Lesions enlarge, exhibit water soaking, and become darker in color. Large areas of leaves and canopies may be affected. Infection is more apparent after flowering. Within a field, earlier maturing varieties may show infection first. Infection tends to be more localized in the middle to lower portions of the plant canopy due to the long incubation period of 10 to 14 days. Moderate to severe infection can cause premature defoliation. Irregularly shaped water-soaked lesions may form on pod walls and sutures and affect seed quality and total yield. This graphic compares symptoms of the 3 bacterial diseases. Factors favoring disease development include the incidence and severity of last year's epidemics of halo blight, bacterial brown spot, and common bacterial blight. Bacterial pathogens survive on and within previous year's bean debris. Volunteer beans then provide the bridge between last year's debris and infection sources, which can then contaminate this year's bean crop. Lack of a crop rotation can contribute to this season's disease pressure. Continual cropping to beans can aggravate disease outbreaks. Bean varieties can differ in their reactions to bacterial pathogens. Some varieties are resistant. While others are more susceptible. Bin run seed can increase the likelihood of disease outbreaks during periods of favorable weather. Bacteria can be spread between plants and fields by wounds from mechanical implements, storm damage, and irrigation practices. Multiplication and infection are favored by low to moderate temperature for halo blight and bacterial brown spot, moderate to high temperature for common bacterial blight, and high moisture for all 3 diseases. Disease management strategies should consider the following factors: reduce seed loss during harvest, thorough incorporation of bean debris, and aggressive elimination of volunteer beans. Rotate with crops such as corn, small grains such as wheat, sunflowers, and vegetable crops. Avoid growing susceptible varieties. Plant certified seed during recommended planting periods. Use timely cultural practices. Avoid excessive and frequent irrigations that may extend leaf wetness intervals. Protected copper bactericides can reduce spread of and damage by bacterial pathogens. 2 to 4 sprays at 30 to 45 days after planting improved yields by nearly 10% in grower fields. Net returns were $25 to $50 per acre in these university tests, depending on disease pressure. Ground rigs should use 15 to 25 gallons of water per acre on a 7 to 10 day interval and may be integrated with other practices. Banded applications are effective during the early vegetative stages. Chemigation should use less than 1/4 inch of water per acre to minimize runoff and dilution effects of the bactericide. Aerial applications should use 4 to 5 gallons of water per acre. Regardless of method, early disease detection and applications of an appropriate bactericide can enhance bean canopy vigor and health. In summary, follow a sound integrated pest management approach. Sanitation should incorporate last season's bean debris and pathogens and reduce this season's volunteers. Crop rotation should include beans only once every 3 or more years. Plant certified seed of the most resistant and adapted varieties available. Follow a moderate fertility program and timely irrigations as needed by the crop. Avoid excesses. When disease conditions threaten, use appropriate bactericides to reduce bacterial pathogens and maximize plant canopy development. This concludes the Bean Videograph on integrated pest management of bacterial diseases of beans, sponsored in part by Agtrol Chemical Products and the Colorado State University Integrated Pest Management Program. Thank you for your attention and enjoy the other segments of this educational series.